passenger. And when he's driving, I feel alive. Half sick with the thrill, complete wrongness. I don't fight him. I don't want to.
All right. Hopefully everybody can hear me. I think I've got the sound mostly figured out. So, yeah. I'll be streaming tonight mostly for posterity, but if a couple of people want to hang out, that is totally cool. I'll try to keep an eye on the stream. But the Bagel Bite boards came in. All the way from China. Man, that was fast. So, they look pretty good. And I'm excited to get one put together and see if they work. So I think that's what we're going to do. Let me pull up chat here, make sure I'm not going to miss anything. All right. Also, I am eating dinner, so hopefully y'all don't mind. This is going to be a pretty casual stream. So, actually, I've been waiting. I have not gotten to do this test yet, but if you were here during the last stream, you will remember that the reason that I chose this width for these panels is because I want them to slide into the rails on a toaster oven so that I can use it as a reflow oven without having to put it on top of a wire rack or some other carrier board. So, I'm going to grab this toaster oven over here and we'll see how good a job I did measuring that. Okay, so here is the toaster oven from the last, well, from the stream before last, a couple weeks ago. And here is our panel. Let's see what happens. Oh, look at that. It sits right on that shelf. Oh, that makes me so happy. So I was a little bit worried about this board thickness. I went for the 0.8 millimeter. Usually, hobbyist boards tend to stick to the 1.6 unless it's a sewable thing. Then those usually go thinner just because they can. I was a little bit worried about this thickness for a panel this size because of the amount of flex that's in it. And if it's sitting on this shelf, it'll bow a little bit in the middle. But honestly, it's not bowing that much, and even if it's a little bit bowed, there aren't any heavy components on these boards, so the surface tension of the melting solder paste should pull all the parts onto their pads, regardless of sort of the angle of the board. So yeah, that's good to know. I can go down to 0.8, looks like. So anyway, since we don't have a reflow controller for this oven yet, and that's what these boards are for, I figure we will hand solder. Whoops. Sorry for bumping the camera. Ugh. Alright. Figure we'll hand solder one and see if we can get it fired up, at least do some electrical tests on it. I really wanted to do this tonight, so I was not able to find all of the parts that I need to populate one of these boards, but I was able to find products that contain all of those parts. So I'm going to be using hot air to pull a few things off of a few different boards so that we can put one of these together. I'm going to take the 32U4 TQFP package off of this Makey Makey. That's the only thing that I had on hand that had one of these. I guess on the, the pot, looking at the bright side of this, this IC probably has a bootloader on it already, so that'll be nice. I also have an Arduino Pro Micro at 5 volts. That has the crystal and all of the passives on it that I'll need, as well as the micro USB connector. But I also dug through a giant bucket of SMD parts in SparkFun Production. It was we have this big bucket of parts, SMD parts. It's almost like a little sandbox because everything's like 0402 and 0608 size parts, and it's just like a fine sand of silicon, I guess. But anyway, it's all the parts that the pick-and-place machine spits out because it doesn't like them, or things that are left at the end of a reel. And I went down there and went scavenging for the parts that I needed. I didn't find everything, but I did find a couple of crystals and the micro USB connectors that I need. Actually, these are not... It turns out I used the wrong micro USB connector footprint. So these are actually the nicer ones that have little plastic pins that stick down through the board. Give them a little bit more mechanical security. Unfortunately, I used a footprint that doesn't have those holes, so I'm just gonna, I guess, either melt those posts down with my soldering iron or snip them with some clippers and then solder them in place, and they'll be fine for testing at least. I also managed to dig up one of these breakouts. This is the breakout for the thermocouple amplifier. So we'll grab that part off of there and the associated passives. And then screw terminal. This is actually two position screw terminals. The cool thing about these, if you've never worked with these before, is that they have these slots on the side. I don't know if I can get a focus. They have these slots on the side, so they actually just slot together. So this is two separate units, and they're just slotted together. And as you can see, they fit in a 4-position footprint, no problem. So that's the plan. So the first step is going to be to fire up the hot air. Let's see if I can get this into focus. There we go. Fire up the hot air and get all of our parts off of it. Well, we'll get the monolithic parts off these boards. Leave the passives where they are, because if I pull them off the board now, I'm going to lose them. But yeah, we'll get... I guess we'll start with the processor. We'll pull it off of the makey, and then I'll hand solder it onto here using solder wick trick. I'll just flood it with solder and then pull off the extra solder with some solder wick. And that should leave us a pretty tight solder job, considering it's a TQFP and I'm doing it by hand. So, I don't know if I can optical zoom you guys, but I could give you a digital zoom. Maybe you could see what I'm doing a little bit better. First things first, let's kind of... There we go. And... let's see, what are we on now? Laptop and HD. HD cam, properties. Yeah, we're just going to do it this way. Hold on. And I'll do a manual focus. I think I can do that with this camera. Yes, I can. This is not what webcams are made for. Does not like doing this. You know what? Let's see if we can just get closer. At least get within the field of focus here. Oh, you know what? Here. I'm going to turn this camera off so I don't make everybody seasick. And then I'll bring you down on a little mini tripod right on the table here. I've done this backwards. Why is this the hardest part? There we go. Yes. All right. All right, that should be a major improvement. And actually, I think that's still zoomed in a little bit, so let me mess with the camera controls a little bit. I'll just let everything run auto. Yeah, there it goes. All right. Nope, it was not zoomed in. Cool. So let's do some soldering. Or desoldering, as the case may be. All right. Let's see, less air, more hot. Get the air station fired up. Have a bite of dinner. That white solder mask is going to yellow like crazy under this heat. Yeah! Oh, so clean! So clean! Oh, it's awesome. Alright. That went very smoothly. So, next step, let's pull that 8-pin SOIC. That is the thermocouple amplifier. I'm going to try to do it right out from under this connector, but I may have to remove the connector destructively because I don't feel like desoldering that thing. Oh, look at that. Sweet. Nothing a little hot air can't handle. I am going to have to remove that connector eventually to get to the caps under there. No big deal, though. Alright, so that's the two big parts off of their donor boards. So let's solder them onto the bagel bite. I keep closing all my windows here. Sorry about that. I know this makes for compelling television as I check all my statuses here. Alright. Cool. Alright. Let's do some soldering. First step, soldering iron's already on. It's, this flux pen might be kind of dry. Let's get it started. And we'll put a little flux on this bad boy. Solder, and we'll place this component. Oh good, I did leave the silk on that footprint so I can see the orientation. So there you can see the dot in the top of the chip and the dot on the footprint. I'll line those up. Feels like there's something under there. Wonder if I've got some solder still on here. Oh, I've got some solder and some bent pins and some thermal paste that was on the bench here. Good, good, good. All right. Boy, that was not the way to handle that, was it? Let's love the soldering iron. This is the Hakko FX951. It's the one that I use at home. At the office I have the oh, what's the other one everyone has? The FX333 or something like that. And that's a great iron, but this one, man, this little pencil style soldering iron is just so nice. And it heats up so fast. What was I doing? Oh yeah, I'm going to clean up the the legs on that 32U4 that we just salvaged. Really, I'm just heating up all the solder on these and making it flat, even if it makes bridges, because when I sit this thing down and solder it, I'm going to flood it with solder. I'm going to make all the solder bridges. And then I'm going to use a piece of solder wick, copper wick, and wick off all the solder that I don't need. And it should leave enough on there to make a good connection. So let's see if we can coax this thing back into the right position. It's sitting much more flat now, which is good. I don't usually have so much trouble with this, but I have had a lot of coffee today. Which I don't usually do, because it irritates my anxiety disorder, but I didn't sleep much last night, and I had a lot of writing to do at the office. Which I'm not... I don't particularly have the patience for anyway, but when I haven't gotten much sleep, it's much worse. Alright, so I'm going to hold this thing down and just get it tacked on the corner there. And then I am going to put all kinds of solder Oh no, that was the side I tacked, wasn't it? That one's smart. Let's see if I can shift everything a little bit, just a little bit, without heating up everything beyond. There we go. Alright, that'll work. So now we'll do the other side. Ideally, you want to keep the solder lower on the on the part that I'm doing, but I'm trying to do it for the camera a little bit. And, you know, we can clean it up no matter what. Yeah, so I'm just like flooding this whole side of the device. I'm going to do that on every side. And I think it's going to be okay. Unless physics has changed significantly in the past few weeks since I've done this last. In which case, we are in trouble anyway. Well, that should be enough solder, huh? So, now, the part that makes it look like I know what I'm doing. Take a little bit of this Tech Spray Pro Wick, size number 2. This is the good stuff. Or at least I think this is the good stuff. In my opinion, this is the good solder wick. And we've got a little bit, well, let's tin the tip of our soldering iron. Just want a little bit on there to whet the wick. And then we'll lay some solder wick here. And boom! Did I do it? Kind of looks like I did it. There might be some bridges in there, some cold joints, but looks okay to me. Good enough for a prototype, good enough for hand soldered. Let's work our way around the device. This pin is bent at the end here. It's soldered to the pad though, so I guess I'll leave it alone. No need to harass it yet. Move on to the next row of pins here. That beeping sound is the soldering iron heating up every time that I pick up the wand. So the base has a sensor in it. Every time I put the wand down, it cools down a little bit to keep from, you know, putting too much fatigue on the tip. And I guess from burning everything down. And when I pick it up again, it heats up and beeps to let me know when it's ready. The rosin flux in this wick, in the solder wick, when you vaporize it with your soldering iron, it smells great. It smells like cedar wood. It smells so good, which is terrible because it's probably giving me cancer. But it's better than smelling bad and giving me cancer, I guess. Not to make light of cancer, of course. No, fuck it. Yeah, we should make light of cancer. Let's not get... Can't fix it. Let's not be sad about it. Can't fix it yet. Man, Man, this thing just heats up so quickly. I love it. All right. Ooh. So I'm just kind of doing a little visual inspection here. It is not beautiful by any means, but it's on there. There's one pin that's given me reason to think that something's not good. Actually, there's a whole row of devices on one side that look like they are not quite soldered down. I may need to apply a little bit of mechanical persuasion. See what I'm talking about? Got these lifted pins. All the other sides look good. But this thing went down crooked because I hot aired it off of another board. So there was solder on some of the pins that lifted the device. What I could do is heat the whole thing up and push down on it with a pair of tweezers and hope that fixed the problem. In fact, that's what I'm going to do. I'm going to try not to heat this whole thing up too much. But we've got 80 of the damn things. So, worst comes to worst. Grab another one. Start over. Alright. Felt it move. It's a good thing. See what kind of damage we did here. Focus. Okay. That looks okay. That, I think, was the problematic row. I could be wrong about that. And it looks good now. Oh no, we're coming up on the problem row. Let's see what it looks like now. Still a little bit lifted, but you know what? We can make that work on a prototype. Let's get in there with the iron. Oh yeah, we can make this work. This is no problem at all. This whole side of the device appears to have had some pretty bad luck. And it's probably my fault. I think it might work, though. I mean, it is not good. I think I've actually lifted a pad, but I think it'll work. Oh. Forgive me, Aunt Mel. Alright, let's see. I'm going to grab some rubbing alcohol. And these tissues that I was using for thermal compound earlier. We will. Actually, rubbing alcohol does not work very well on this flux. Water works a lot better. But this will at least get us cleaned up enough to continue our important work. Yeah, it's just so not good. Alright. One down, couple to go. Let's put that on. Did I leave any sort of polarity indicator on that SOIC pad? It does not look like it, does it? Let's take a look real quick at the data sheet. Okay, so this is the data sheet for that part, and what I'm looking for is a pinout. I'm hoping, here we go, that it'll be obvious where the heck I intended for this thing to go based on the pinout. So if I look at the device up close, So I've got an idea of the orientation of this thing anyway. So ground is going to be on this corner, and clock is going to be on this corner. Which is interesting. A lot of the time you'll have ground and VCC on opposite corners, but this has them on opposite ends of the same side of the device. Okay, so that's easy enough. There's the ground pad, and there... on the other side... Okay, sorry. Let me bring you guys back on back on the camera here. I think this is the proper orientation of this part. I think. So we're gonna go on that anyway. And again, this has balls of solder on the bottom of its feet. They're gonna make it tough to get flat unless I hot air the whole thing, which I can certainly do. You know what? I am going to do that. That'll at least get us started, and then we'll go in with the iron afterwards and shore everything up. But yeah, I like the idea of using the hot air to get this thing sitting flat. We won't run into the same problem we did with this. We will very likely run into a different problem. I suspect that that's warm enough. Yeah. So we'll just touch those up with the iron. And that should be the last time we have to use hot air here. The rest of the stuff should go on no problem. Well, we will have to use the hot air to desolder some components from their donor boards, but should be soldering with it after this. You see how ugly my hand soldering is? This is why I don't work in production. Is also why I am working on a reflow oven and a pick and place machine so that I don't have to do this. And no one has to put up with this from me. Okay. Next on the list. Let's put the crystal on. So let's pull the... Since this is running at 5 volts... Is this running at 5 volts? Is that the idea? Yeah, that's right, because I had to put a VRAG on it for the... for this device, which is a 3 volt device. Ooh, dirty fingernail. Sorry about that. So yeah. So here's a 5-volt Pro Micro. So it's going to have the 16 megahertz oscillator on it. So we will pull that off with its associated load capacitance and put that on our board. Could I have just taken these two boards and soldered one to the other and made exactly what this board is? The answer is yes. But then I wouldn't have gotten to do a stream about board layout. Also, for something that's going to become a tool for the shop, I like having a nice, clean, dedicated piece of hardware. Which isn't to say that the shop isn't full of hacks right now, because it most certainly is. And I'm one of them. Alright. So we have a crystal and two capacitors. They're going to find a home right here. This crystal is going to be a little bit tricky to hand solder. I'm just going to have to kind of... I did use a footprint that has a little bit of extra length on it. See how there's a little bit of overhang? So I can get my iron in there and flood the solder in under the pad. Now, two of these are crystal and two of these are ground, no connect. So I should check to see which way this thing is supposed to go. No, wait, that doesn't make sense, does it? It doesn't matter. If they're catty corner and you spin it 180, it's still correct. Yeah, what am I talking about? Doesn't matter. I've done this before. I swear. You know what? I lied. We're going to use the hot air again. Get this thing flat. Yeah, that'll work. Alright, that got pretty warm. Yeah, it's down. So now we will just touch these pads. Outside corners here. And I should have enough flux on there. Yes. The solder will just wick right up under the part where we need it. All right. It's on there. What a mess. All right. Now, somehow I managed not to fling these capacitors across the room. These are the load capacitance for the oscillator. Generally speaking, it is not a good idea to put solder on your iron and then try to transfer it to a part, because the solder has flux in the middle of it, and that is what makes it flow and wet to the surface that you're soldering. And if you melt the solder onto your iron, the flux burns off at the iron, and then you just have this mass of rapidly oxidizing hot alloy on the end of your iron, and it's not going to want to stick to anything. However, in this particular circumstance, I am going to flood these pads with flux from this pen. These Kester flux pens, by the way, are fantastic. And since I don't need much solder on the other end, I am going to put just a little dab of solder on the tip of my iron. Basically like you would if you were just trying to tin your tip. And then I'm going to basically transfer that to one side of this tiny, tiny capacitor. That's the idea anyway. Wish me luck. There you go. Relatively painless. And that's how you, well, that's how I do that. I don't know if that's how that is done. We got another one. My cream cheese wontons are cold now, and that is just a really weird flavor profile now. By the way, how gullible are Americans that you can give them a folded up wonton wrapper full of cream cheese and tell them, oh, this is Chinese food. And we're like, oh, yeah, it is. That sounds Chinese, right? Deep fried cream cheese. Okay. Can't tell if I found a solder bridge on that TQFP part or if it's a little bit of tissue paper from cleanup. It is a little bit of tissue paper. Good. That's better than a bridge. All right. So now we have a couple big connectors and some more passives. So let's go ahead and put all these little tiny passives on the board. Oh, actually, you know what? Let's skip to the VRAG, because that'll be fun. A little SOT, what is that, a SOT 23.5? We'll do that. But first, we will steal one. And we will steal it from this here Pro Micro. I'm waiting for the hot air station to heat up. Might as well have another bite of cold wonton. Official snack of Signal Ditch. Cold wonton. Ba 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 ba. Let me grab something to put these on that isn't just the bench top here. The top of this table, it's not actually a workbench, so it's my conference table, and it's covered in urethane, and when I put a hot part down on it, it tends to melt to the urethane a little bit, which isn't good for anything, the table or the part, or anything really. So, alright, so I'm going to put my parts on. This is a piece of FR4 came off the side of the panel, it came off the frame of one of those panels of Bagel Bites. Alright, let's grab these tantalum capacitors. And let's grab this PTC. And we'll probably want a few more of these things. What is this, diode? I do want that diode, I believe. Let's leave the rest of this for now. And go back to our board here. It is strangely non-obvious, from my point of view, where this camera is focused, and I think part of it is because I have the image cropped in OBS. So actually, I need to put this off-center so that it's centered in the screen. Alright, so that SOT 23.5 package, which is our 3.3 volt VRAG, this guy is going to go right here. first a healthy flood of Flux Pen. There. Now I shouldn't need any fancy tricks for this, no solder wick or anything like that. The pitch on this guy is wide enough that I should be able to just get in there with a soldering iron and nail it down. That's it, just like that. Probably got a little enthusiastic with the solder there, but this isn't a production environment. Yeah. Yes. All right. Next, we've got these two big tantalum capacitors, and these do have polarity, so I want to make sure to line up the stripe with the stripe on the silk here. And take a bite of noodles. That could be a little bit straighter. Couldn't we all, though? So I run my iron pretty hot, I'm told. Kind of at the upper limit of what most irons, most hobbyist irons will do. Around 750. Mostly because I like to be able to just kind of touch the components and have them nailed down and not have to worry about them. Also, it's worth noting that I work with lead-free solder. So it does have to get a little bit hotter. But just in case you're not able to replicate my beautiful results at home, and you're wondering, what is his secret? Well, that's it. I get everything way, way, way too hot, and I use the lead-free solder that everybody hates. Actually, this is really nice. Even people who don't like lead-free solder have told me that they like this stuff. This is what we call the special blend at SparkFun. It's an alloy of roughly 96% tin, 3% silver, 0.5% copper, and then just a little bit of antimony. And it's got a water-soluble flux core, and it is... If you're going to do lead-free soldering, it is really nice lead-free solder. It flows almost like leaded solder does. Of course, nothing flows like leaded solder. I don't have anything against leaded solder. This is just what I happen to have on hand most of the time. Okay, so you guys have had a chance to really look this over. I promise this will look slightly better after it's been washed. This, I believe, is a PTC. I didn't make myself a build sheet, so I'm going to open KiCad here. KiCad, however you're supposed to say that. And open the PCB. Yeah, sure looks like a PTC. I am also not convinced that I have these capacitors turned around the right way. I may have done this really wrong. Which is good that I caught it now. Those little tantalum capacitors go off like firecrackers when you hit them with the reverse polarity. Oh, no. I've got it right. Yeah, this is a 3.3 volt and this is a 5 volt rail. So, and the stripe marks the positive side of the tantalum capacitors. So, we should be in good shape. And yeah, we are going to put a PTC right here. And I've very helpfully put a big blob of solder right here on this pad, which isn't great, but what's done is done. Let's put a little bit of flux on here. That's part of why everything looks so nasty right now, is I've got burned flux all over this board. So the PTC is just a resistor, positive temperature coefficient resistor, so it doesn't have any polarity to speak of. So you can go on any way that you want. There we go. That's what I was looking for. That's not so bad. Look, it's starting to look like a thing. All right, so let's work our way around this way. So next, let's figure out what this is. I have a feeling it's a filter capacitor for the output of that VREG. And if that is indeed the case, then I can steal one of those off of this Pro Micro. But I have to see where on the Pro Micro I would expect that exact part to be. So first let's check PCB, layout. This is a 0.1 microfarad capacitor. Let's look at the schematic for the Pro Micro. It does have a 0.1 microfarad capacitor on the output of the VRAG. So let me open the board file on that so that I can see the placement. Well, I guess I could just look at the traces here. It's just a 2-layer board. So that's the VRAG. These are in. Okay, so I think it's this one right here is the one that I want. But I'm going to double check. That's right, I'm going to fire up Eagle to do that. All right. So I am looking at the layout for the Pro Micro. I'm going to click on the capacitor that I thought. It is indeed a 0.1 microfarad capacitor. That is the one we want. So let's steal it. I don't think the protection diode from the Pro Micro made it onto the Bagel Bite. I think I decided that there was no chance of hooking this thing up backwards because the only power supply that I have to it is the USB jack. Which isn't always a safe assumption, but in this situation I think it's probably okay. I guess we'll find out. Okay. There is our capacitor. Let's tack it onto the board right there. That's where it goes. Ugh. My tweezers are sticky with with the flux. There we go. Speaking of which, there you go. Part of a balanced breakfast. Well, just about took my capacitor with it. Come on. That's so good. Alright, there we go. With these guys, no polarity to speak of. Just put it on whichever way feels right. Do a better job than that, though. Yeah, that's okay. We'll get away with that. Get away with that all day long. So it also occurs to me that I did not put any status LEDs on this board that I recall. But I do have this header marked for relay. That's just a 5-volt I/O. So I will jam an LED into the screw terminals here, and we'll run a blink sketch on it and make sure that everything works. Now at this point, if it doesn't work, it could be my design or it could be my soldering, to be honest. Alright, let's get that USB connector on there. I'm excited to get that over with. So the USB connector, luckily we do not have to steal off of another board. I have a couple of them here that I saved from recycling. And these do have little tiny feet, as I mentioned earlier, that I am going to remove so that it will sit flush with the board. And then when I revise this board, I'm going to use the footprint that has the drill hits to accommodate these little feet, because they do lend quite a bit of mechanical stability to a connector that is not well known for its stability. Good stuff. And we'll try to get these pins lined up. I'm going to push this a little bit towards the edge of the board, farther than it's intended on this footprint, so that I have room back here to put my soldering iron and hopefully flow the solder down off of the pad up onto the legs. Before I can do that, I need to tack this down by one of the shield tabs here. And that would have been perfect, except that I made the part jump a little bit. There we go. Still crooked, isn't it? Man. Hold on. Ugh, the situation's not improving. Alright. I think we've got something usable now. Okay. Yeah, so because I'm using technically the wrong part for this footprint, I'm going to have to get in on the backside and bend these legs down a little bit to meet the board. But that's not the end of the world. Alright. I wish that connector could be straighter, I really do. But it's just not gonna be. Alright. So, first things first, I'm going to take my tweezers and get in here and push these pins down towards the pad. And then hopefully it will not be much of a challenge to bridge the remaining gap with some solder. There. You can kind of see what I'm working with back there. This is not a friendly part for hand soldering, but it can be done. I have done it before. Man, I had it. I had it. And then I made a solder bridge. I was so close. So close to looking like I knew what I was doing. Can't win them all. I think that might be on there. I've done worse. Shame to say. Alright, so let's hunt down these resistors. I'm going to take those off of this board because I don't have any on hand. And let me make sure that I'm grabbing the right ones here. I'm going to switch windows over to the board file for this Pro Micro. Okay, so it's these 22 ohm little nothing resistors right here. So we'll pull those with some hot air. Let that heat up real quick. Have a bite of Noodles and check the chat. Okay. There's one. If I can get it off my tweezers. I need to wipe these tweezers off because they've got flux pen on them. And it has made them sticky. Sticky tweezers are not what you want when you're trying to place these tiny little parts. Alright. And two. I'm just going to leave the air on unless the noise bothers anybody. Because I think we'll be using it again real soon. Looking okay now. All right. What is next? How about this guy right here? Let's see what that's supposed to be. Really should have printed myself a build sheet earlier today. I was not thinking about actually having to... It's like, I laid this thing out, I know where everything is. Not off the top of my head, I don't. Come on. Okay, so that thing is going to be a 10K. Yeah, little 10K 0603 resistor. And that is another thing that we should be able to take off of this board. So that's what we'll do. Alright, here we go. This right here should be a 10K. Obviously, it's no coincidence that this board has all of the parts on it that we need to build our board. We basically ripped the schematic from this thing wholesale. Because our board is essentially a Pro Micro, but with a built-in thermocouple amplifier. So this goes right here. So let's get a little flux on those pads. Try not to throw this thing across the room. Shoot. Picked up that resistor with reckless abandon. That is such a satisfying little little hiss. When you got plenty of flux on the board, you just have to just transfer a little tiny blob of solder on there. It goes tss. Whoa! Heyo! We almost lost our resistor. I was heating it up, and then I guess I squeezed it too hard with the tweezers, and off it went. Alright, there we go. Now it's going nowhere. Next. Let's see. So these guys, one of them is going to be a filter capacitor for the power rail on this, and one of them is going to be either a capacitor or a resistor on the analog sorry, on the analog reference pin, I believe. Only one way to find out for sure. We'll have a quick peek at the board layout file here. Okay, yeah, so this is a 1 microfarad cap, and then this is also a 1, so these are both caps, 1 microfarad caps. So, let's see where we can steal some of those from. Okay, so we're going to get those. Here we go. All right, so we're going to get those from right here and right here. Off we go. All right. Those, of course, are going to live right here. Oh hey, I've got Rocketman in YouTube chat says they've got crap internet, but I hope I continue the streams for a long time. Seems like a cool idea for a stream. Cool, thank you. Thanks for hanging out. So yeah, sorry. I know live streams aren't always the ideal format for people because you know, it can be challenging on the internet connection, but yeah, come hang out anytime. I am glad to have people hanging out and, you know, watching me really make a mess of this soldering. I'm really impressed with this webcam. So the webcam the main camera that you're looking at the soldering through right now is a Microsoft LifeCam Studio that I bought probably 3 or 4 years ago now. 3 years ago, maybe? Maybe even 4 years ago. Yeah, wow. And I bought it, when I bought it at the time, I think I paid $80 for it. And, which is steep for a webcam, but it's a full HD, actual full HD webcam. The sound out of it isn't that bad, although that's not what you're hearing now. You're hearing CAD CM217 pencil condenser run through an Alisys Multi-Mix 8 USB mixing board. But anyway, this camera, it is not advertised as a close-up camera, but I have it probably, what is this? 3 inches from the workpiece here. And it seems to hold focus pretty well at 3 inches. And it looks pretty good. I mean, for a webcam. You know, considering it's not a microscope or a macro camera or anything. Oh shoot, that was not soldered down. I made an assumption. I wasn't paying any attention to what I was doing. Anyway, this is a super decent webcam, even considering the cost. I'd like to try the what is the other one that everyone likes so much? It's a Logitech C something or the other that I've heard a lot about and have not had a chance to play with yet. So if I can afford it before too long, maybe I'll try to get my hands on one and add it to the streaming setup here. Right now, every camera that I have is a some kind of webcam, all running on USB. Shockingly, Windows 10 and OBS don't seem to have any problems at all with a whole bunch of USB webcams all running at the same time. It does help that I have multiple USB 3.1 root devices, and having Windows 10 helps, I'm sure, but pretty impressed. Last time I tried to do this was under, I think, Windows 7 with an older laptop, and man, it did not go this well. Speaking of things not going well, man, these... I need to shut my mouth and just concentrate on the soldering, because these capacitors are just... What am I doing out here? I mean, here's a reason to watch the stream right here. Hang out and feel better about your own soldering. Because I am just smearing these things. Alright. But, prototype, right? Man, we are mostly populated at this point. So I think the next thing we'll do is this guy right here. Looking at the board file, that is going to be a 0.1 microfarad capacitor. And I happen to know that this is a 0.1 microfarad capacitor. So it's coming with me. what? I was all set up to solder this thing, and I realized we haven't put on the flux pen yet. That magic solder juice makes the solder joints good. That went a lot more smoothly. I shouldn't knock on wood. That's one side. Yeah, I think that's on there. That looks pretty good. Wish they could all be like that, huh? Alright, so next, the passives associated with the thermocouple amplifier. We will be pulling those off of the thermocouple amplifier breakout board, naturally. I'm going to remove the connector, the thermocouple connector, from this breakout board destructively, because I do not anticipate using it. And it's a lot of copper to heat up just to get this part off. There we go. Alright, so all the parts we need should be there. Just gotta figure out which ones are which, where they go. One of them is very straightforward. Because, as you can see here, we've got a capacitor sitting between these two pins hooked up across them, and over here we have the same arrangement, so that capacitor goes right there for sure. So we can go ahead and do that without even looking at the board layout. We can do that without having to know anything. So naturally, I'm attracted to that option. I'm going to take this whole device and go and run it under the sink and then blow it out with the shop air after we're done here, because it is just covered in flux, which makes for nice solder joints, but it does look real nasty until you go wash it off. Alright, that was easy enough. Got a couple, actually these are all capacitors, aren't they? Alright, time to figure out what's what here. Looks like we've got a couple of, well, we've got a 0.1 microfarad capacitor, which is the filter cap for this device. Hold on, I can't see the window. I don't know if I'm pointing right. There we go. It's the filter, power filter for this device, and that goes right there. And then on this side is a ferrite bead, which is a choke for this, basically so that the thermocouple probe doesn't act like an antenna, and we don't end up amplifying noise that it's picking up and sending it to the micro. So yeah, both of these are going to be ferrite beads. And then, yeah, that's another capacitor. So let us have a look. Okay, it's pretty obvious which of these are the ferrite beads. Both because they're darker in color, which is generally holds true in my experience, and also because these were the footprint for the connector for the thermocouple probe, and there's one teed off to each of those. So we know that those are our ferrite beads, and this is going to be our 0.1 microfarad cap. So let's go ahead and grab all those things while we're here. And we'll solder those onto the Bagel Bite board. And then we will relax and solder the nice big screw terminals, which will be like a vacation after all this surface mount stuff. And then I guess we'll plug it in. We'll plug it into the laptop. What could go wrong? We'll clean it up first, actually, but yeah. Boom. We have already slathered the area in flux pin. Got a ferrite bead here. Sorry, doing a little bit of stream management. Alright. Where were we? Another ferrite bead, I guess. Nope, that's cap. There we go. Grab another ferrite bead. That'll go right here. Let's hit the other sides of those. Should be a 0.1 microfarad capacitor. Looks like I've lost it. Oh, nope, there it is. Boom. We're going to put that right here. With any luck. Okay, stay on the tweezers. See what happens. Yeah, alright, dude, I think that'll do it. Now, let's see, a bunch of water is going to get trapped in here if I wash it after I solder this big part on. So I'm going to go run this under the sink, try to scrub off all of this flux. Then I'm going to blow it off with the shop air, and we should have a much cleaner looking board. Then we'll solder this guy onto here, and we'll plug it in and see if it does anything. Like destroy my USB bus. of shop towels. That's not great. Alright. Let's hit some air. Make sure there's no water trapped under the ICs. I guess it's not a bad mechanical test for the solder joints either. It's also not a great idea if you have parts on your board, that, especially discrete transistors, things like that, that are going to be particularly what's the word I'm looking for? Sensitive to electrostatic discharge. Blowing air across something like that does create quite a bit of static buildup. But here we go. Look at that. We made a thing. Told you it would look a lot better once we cleaned it off. That almost looks like a thing, huh? Okay. Put the camera down. I'm going to solder this on. Give that a little bit of flux. Yeah, it's straight, reasonably straight. Oh, this is the ground pin, of course. Takes a little bit more heat because you got to heat up the whole copper plane around here. All right. Well, in theory, this is a finished working device. In practice, there are quite a few solder joints on this thing that I am not sure about. So, let's just see what it does. I'm going to see if I can track down a 5mm LED that I can jam into the screw terminal between relay and ground. And we will use that combined with the Arduino Blink Sketch to see if we have an actual working thing here. So, let me take a few bites of rice here, and then I'm going to hunt down an LED. I'll be right back. Should have limitless LEDs. strange thing to not be able to find. Gotcha. Oh, classic red 5mm LED. And I need a small screwdriver for that screw terminal. And we're off to the races. Oops. Those are flatheads. This isn't gonna work at all. I have a tiny standard screwdriver. I might not. I might have to improvise. Oh. I do. Good. All right. A little underprepared there, but made it through. So I'm just going to bend these leads until they're about the same length at the end. And jam them right into that screw terminal. And then if we can upload the Arduino blink sketch to this and get it blinking, I have a K-type thermocouple here that I will hook up to it, and then we can confirm that the thermocouple amplifier is working. So let me return the camera back up onto its perch. And we'll plug this thing in and see if it fries itself or fries my computer or works. That's always an option. It could work. Black out the camera there for a second while I do this so I don't make everybody nauseous. Boy, this little camera gets warm. It's no joke. Okay. That should be kind of reasonable. Let's see what that looks like. Alright, so here's our device finished. This is now our device under test. So, I need a USB micro B cable. Which I have. Oh, no, that is not one. Oh, I know. I know. I've got one over here. There we go. I'm using all of my USB cables right now. Alright. Which I have right here. And I need to plug this in. Scoot this. I need a USB-C adapter. There we go. Moment of truth. I'll put my thumb over this so I know if either this VREG or this IC get really warm. So my computer hasn't detected a device, but nothing's really warm. So let's pop open the device manager and just double check. And then we'll inspect some suspect solder joints. Probably starting at the USB connector itself. Yeah, I don't see it in here. Ooh. Okay, I think the USB connector could use a little bit more solder, is what's going on here. So that would stop anything from happening. Let's let the soldering iron heat up here. Should take just a second, literally 3 more seconds. All right. Can't tell if I'm making things better or worse. But that looks pretty good. We'll leave the soldering iron on. Again, still nothing is warm. Let me grab a multimeter. And we will begin the troubleshooting process in earnest. So I'm going to find so we should have across each of these capacitors, we should have on one we should have 5 volts. Just looking a lot like 2 volts right now. On the other one, we should have 3.3 volts. That's also looking a lot like 2 volts. It's not great. So let's... Okay, we got 5 volts coming in. Let's see. 2 on one side, 2 on the other. Man, it's just 2 volts all around on this thing. That's not what you want. That's not what you want at all. Man, you just hate to see that. Let's see if we've made a bad assumption about one of these parts. I'm going to wander over. Okay, so this should be a mic 5219. We should be seeing 5 volts on both of these legs. These are the inputs. So we go from ground. We know this is good ground because if I touch here, I get 5 volts. If I go here, oh, there's 5 volts there. There's 5 volts there. 5 volts there. And 5 volts there, okay. So this leg should not be at 5 volts. This leg should be at 3.3 volts. Is there a potential difference? There is a potential difference on the ground. Ooh. Okay. All right. I think this all comes down to the USB connector, guys. I have done something goofy in soldering this. So, I'm going to look the pin out for that connector. I believe we do not need this pin, so it should not be connected to anything. And indeed it is not. This, on the other hand, is a ground pin. Okay, and does it have good continuity to... Yeah. Okay. Okay, I gotta hit that ground pin again. That's what's going on here. This, for anyone who just tuned in, this micro USB part is not the part... Oh, sorry about that. Is not the part, the correct part for this footprint. It is one that I had on hand. So that's why it's giving us trouble. I just put a big old glob of solder on there, though. With any luck, that will have us all fixed up. Excuse me. Hey, that sounded good. Oh, okay, so the last firmware that was on this was Makey firmware. And so I've just plugged this in, and it is pulling my cursor continuously down to the bottom of the screen, which I'm guessing is one of the functions that was on the Makey. And it's doing that because, there we go, one of these pins was pulled. No, alright. So now we've got scrolly action. Okay, so this is a mess, but let's see if we can, here, let's unplug it. It had taken control. Let's open Arduino. We'll open the Arduino IDE, and then we'll plug it in, and we will hit it with new firmware real quick. Ooh, a bunch of stuff has stopped responding to actual mouse clicks. There we go. Alright. We're in much better shape now. Let's get Arduino open. Now, I do not remember if we had a special... if you're just tuning in, I pulled this chip off of a Makey. I do not remember if there was a special Makey bootloader, or if we used some version of our existing 32U4 bootloader. I also... There we go. I cannot find my Arduino window. See, sometimes I have, or a lot of the time, my laptop is plugged into an external graphics card with 2 displays, and so right now I am battling a problem where the last time Arduino was on screen, it was on the other display, and I cannot remember. Here we go. Move. Yeah, every time it spawns a new window, it spawns it on a display that is not here. But if I can grab a hold of it, then I can drag it over. Sorry about this. This is a really stupid technical difficulty, as technical difficulties go. Alright, we have an Arduino window. Going through the board manager here. Yeah, there's an entry for Makey Makey, so I'm going to assume that that's the bootloader that's on here. We will plug it in. Oh gosh, it's taking control of the mouse again. I'm jamming my fingers onto the pins of this controller. Just upload anything. Anything that isn't Makey Makey. There we go, get its attention. Alright. We've successfully put some firmware on it that is not trying to take control of the mouse and type a bunch of nonsense. Excellent. So that means it is taking firmware, so that means that we've done at least part of our job right here. So now, let's put blink on it and see if we can get this LED to blink. Because that's the ultimate test, isn't it? Alright. So, examples. Basics. Blink. Now, which pin did I connect the relay pin to? That's a question for the board file. Actually, that's a question for the schematic. Let's see what that looks like. Pin 13. All right. Let's see if we can make this thing blink. Hey, look at that. It works. Despite the ugly soldering job, it works. Well, the relay pin works at least. And we know that this is soldered right, and we know the crystal's soldered right. Boy, that's just good news all around. I guess, let's see, what time is it? Oh man, it is after 11. Let's load some example code on this board to try to read this thermocouple. And if we can get that to work, then I think we'll call it a night. And then I'll do another stream maybe tomorrow night, later this week maybe. And we'll actually install this in the toaster oven, and we will start doing the programming for the application, the PC application that's going to actually run the heat profiles on these. So let's see, step 1. Let's unplug this guy, and it does matter which way these things go in. But also, I have a 50-50 chance of getting it right. So in the final toaster setup, the thermocouple will attach here, like I've just done. And then instead of an LED, this will be connected to some leads that will attach to a solid-state relay. And then the solid-state relay will be connected to or connected across, I guess, the heating element for the toaster oven. And that'll allow us to do, what do you call it? A thermostat. You know, make a PID loop and hold certain temperatures. Let's see. So let's see if I have, I don't believe I have example code loaded on here for this part. I don't, but I can grab it real quick, and I can bring you guys along while I do that. There we go. All right. I cannot remember the part number of this thing now. Max 8, no, max, there are only so many digits, right? This is a stupid way of doing this. Okay. I did not realize we had that in. Well, let me make sure that I have us as a... Okay, cool. Did not realize we had that in the library manager. Boom. Okay. So let's see. I set the chip select pin as 8, looks like. This isn't particularly important because it's always powered. I hope this firmware doesn't rely on being able to turn the chip on and off. Okay, it does rely on serial. I think just plain serial on the 32U4 still goes to the USB. And serial 1 goes to the actual UART. Is that right? Well, we'll give it a shot. Ooh, plug it in. Okay, this is a positive result. Fault, no probe. Which means that we are talking to the chip, which is good news. Now this probe, I have seen probes in better shape, so it could be that what we have here is not, in fact, a K-type thermocouple. It is, in fact, just some junk wire. But, like I said before, I had a 50-50 chance of getting it wrong, plugging this thing in. So let's see if that's my problem. If that's not my problem, it could be the solder work on either of the ferrite beads or the probe connections on the SOIC part, or the capacitor between the two thermocouple leads. That decoupling capacitor. I do wonder if I got that value wrong. That would mess with things. So let me unplug this and swap these leads around. Tighten that back down. Plug it back in. Okay, let's see what it said at the beginning there. All bits were 0. Oh. Something is going on. It doesn't like something that's happening. And it could be literally anything. Mosey Mizo and clock pins all look like they have a good solder joint. Let me double check the orientation of the part. Here, let's put the camera back up on stream here. Also, I wish this thing would focus. I know you all wish this thing would focus. All right. Yeah, let me check the orientation of this part. I believe I have it right, but obviously something is wrong. No, it looks like it's correct. So that's not our problem. Let's see. The leads from the probes look okay. Let's see if we've got continuity from the from the probes back to the IC, back to the amplifier. Do indeed. And I couldn't have gotten that capacitor value wrong because I took it directly from the other board. Let's see if chip select and all of those are appropriately assigned. Okay, so chip select should be one of these two. Let's see, this is ground, so this is chip select. We are looking for chip select to be connected over here, I believe. And it is. Oh, this is interesting. This is interesting and yet not surprising. We may have some solder issues here. Let's see. Well, no. You know, on the other hand, that looks okay. Let's see. So that's chip select. This should be slave out. So I would expect for that to be connected right here or right here. And then this would be clock. Boy, that all looks real good. I'm willing to blame this thermocouple. I think that that's what's wrong right now. We will try again later with another thermocouple probe, and then if that doesn't solve the problem, then there is obviously something else going on here. But I think it's safe to say, for now at least, that this board works. So on the next stream, we will be installing it into our toaster oven, and then we'll install some fiberglass insulation, close up the box, and we'll have basically a reflow oven. The only thing we'll need to do from there is to create an application that connects to the Bagel Bite boards over serial, and then controls them and actually does the thermostatic control, and also does all the timing for the heat profiles. So that'll be the next stream. Let's go take one last look at the code here and make sure there's not something obvious that I've overlooked. No. Let's see if it gives us a different error if I actually don't have anything connected. Okay, so OC fault, no probe. We're going to remove these leads. Give it a good hard reset here. No probe yet again. Huh. How very, very odd. Let's make sure this thing's only getting the power that it's supposed to. Whoa! Something's wrong. The 3.3 volt bus is sitting at 4.9 volts, which is not where that's supposed to be. So something Something is borked. Something about our VRAG, I suspect. I wonder if we have perhaps stolen the wrong part. What are the chip markings on this? M. That's not promising. No. Why would that be there? Why would that be there? Well, let's unplug this. As long as we know that we're over voltaging this part. Hopefully we haven't destroyed it. It does it will tolerate a voltage up to 4.5 volts. So we weren't killing it, but I imagine because it is an amplifier that over voltaging it was affecting the output to the amplifier stage, and then the I2C stage was, or I'm sorry, the SPI stage was, you know, just reporting really weird results. That's what I'm hoping. Really doesn't look like this part that I pulled off the Pro Micro is the part that I was expecting to find. Which is puzzling for really a lot of different reasons. Oops. Extra weird. it really looks like the supposed Mic 5219 voltage regulator that I pulled off of this Pro Micro is not, in fact, the correct part. It looks like the part that I have on here is a lithium battery charger, which is disturbing because it means that a whole bunch of these were probably built up wrong. So I am going to go investigate that tomorrow. But in the meantime, let's see if I have anything that does have a 3.3 volt regulator on it that we can swap in. Now the good news is, unless you happen to be running this design at 3.3 volts, that VREG never actually comes into play. But nonetheless, it's a little disturbing. Let's see, what might I have that has the correct part on it? Oh, huh. What do I have? A couple of old Unos over here that have the right part on them. Not that I could see if it did. These might be our best bet. An XB shield. No, it's XB USB. XB USB should have. Yes, LG33. This is a mic 5219 for sure. So let's swap those out. See if it makes a difference. Spoiler alert, it should. Waiting for the rework station to heat up. Oh, I had it. That was a slam dunk, and I moved it too soon. All right. Let's give it a quick touch up with the iron. You wouldn't believe it, but this board I was just blowing 500 degree air at is quite warm. Okay. Power. Come on, big money. 3.9. But that is much closer to spec. Full volt under where we were. And to be fair, this part is quite warm right now, so it's probably not operating at optimum efficiency. Let's see. Well, hold on. First, let's make sure that this is getting that voltage. It is. I believe that's within spec for this part anyway. So, let's attach a probe and see what Arduino has to say about it now. It is still acting weird. Still behaving suboptimally. It does look very much like it's speaking to the chip, which is good. I don't know if I want to dig into the library in this stream and find out where those error messages come from and see exactly how much spy communication has taken place. Get to that point. Alright, let's go find that error, that error string. That's what we're doing now. I'm going to cut this stream off at midnight either way. But in the meantime, let's see if we can hunt this down. So, checks fault bits. So we get this at first. A couple times, and then we start getting this. So it may very well be, because it doesn't look like there are any error messages in particular to tell me whether or not this device is talking. It could very well be that it is not. And there's any number of reasons why that might be. Could have the chip select pin wrong. Or misconfigured. Let's have a look at that real quick. Chip select pin equals 8. Let's see what it actually is. Okay, so it's connected to slave select. Ah! I have the chip select line wrong. Oh, that's a relief. Okay. So what my problem is I put 8 in the Arduino sketch when in fact pin 8 on this device is D17 in Arduino. Which is a stupid mistake, but it's a stupid mistake that I am happy to have made. So oh, guys. All right. Look at this. That's probe temperature data. That is awesome. See how much it went up just now? That was me. I stuck it in my mouth and was breathing on it. Now I'm blowing on it. See if I can cool it down. Okay, so it's a little all over the place, but you know what? I think it's working. And oh, you know what? I'll bet I have it in backwards. Here's a thing that these chips love, is when you swap the probes while the device is powered. Okay. Okay, so there's some investigation to be done here, but all in all, I think we have a working circuit. That is beautiful. All right, one closing victory shot. Have a look at we'll have a look at what we've accomplished here. Let me remove our test LED, test blinky. Coil up our thermocouple probe. There we go. That is a bagel bite. The first one, and it works. Holy cow. It doesn't get any better than that, does it? Well, actually it does, because I have a couple of edits that I would like to make to this thing. And I'm going to jot down some revision notes and then send these things out for revision. But I'm going to go ahead and build up all of these because my revisions are mostly aesthetic. And I have plenty of panels of this device. So, yeah. This will be the first thing that we load up in the pick-and-place machine. And we'll use this as sort of our test bed for figuring out how the pick-and-place machine works. Yeah, so that's it for tonight's stream, which is perfect. Right at midnight. Midnight Mountain Time, anyway. And I will see you guys next time, where we will finish the toaster oven to reflow oven conversion, now that we have a working board. And we will write the application to drive that. Sweet. Later, y'all. Happy hacking.